Okay, good afternoon. So again, welcome sa ating lecture 2 for computer system organization and architectures. So we will be moving on to our lecture 2. So our lecture for today is the von Neumann architecture. Okay. So von Neumann architecture is the computer architecture that is still used today. So most of the computing system na meron tayo are tawag to based on the von Neumann architecture. So ano ba yung von Neumann architecture? So sabi dito, all computers more or less are based on the same basic design are based on von Neumann architecture. Wait lang ha. Using ko lang to. Okay, are based on the design of the von Neumann architecture. So, ayan. Kahit yung cellphones natin, laptops, desktop, mainframe computers, supercomputers, they are all following the same architecture, which is the von Neumann architecture. So, ano ba yung ibig sabihin ng von Neumann architecture? So, the model for designing and building computers based on the following characteristics. Number 1, the computer consists of 4 main subsystems. So ito yung pinaka-importanting component ng isang computer system na nagfa-follow sa von Neumann architecture. So we have the memory. When we talk about the memory, okay, we're talking about the random access memory. Ano? So when we talk about the computer system architecture, pagka sinabi nating memory, and pinag-uusapan natin ng von Neumann architecture, ang pinag-uusapan nating memory dito is the random access memory or RAM. So, isang tabi nyo muna yung storage. Okay? Mga storage, hard disk drives, flash disk drives. Okay? Those are not necessary included sa von Neumann architecture. Remember, those those storage are for permanent usage. Okay? A computer system following von Neumann architecture doesn't necessarily needs a permanent storage. Okay? Ang kailangan lang niya is RAM. Okay? So, kasi yun yung principle ng von Neumann architecture. So, first we have the memory, followed by arithmetic and logic unit. We have the control unit, and of course, we have the I/O or the input-output. When we talk about the input-output, okay, hindi rin ang pinag-uusapan natin dito yung mga mouse, keyboard, etc. When we talk about input-output, it's the way how data coming and out of the computer system. Regardless kung ano man yung I/O na yan, keyboard, mouse, monitor, etc. Okay? So, yun yung pinaka-principle ng von Neumann architecture. Okay? Lagi yung 3 components na yon, tatandaan ninyo yon. The 3 components of a von Neumann architecture computer system is it must have a memory, it must have a processor, specifically arithmetic and logic unit, and control unit. So, yung dalawang yon, yung arithmetic and logic unit at saka control unit, nasa loob yun ng processor or ng CPU. And lastly, we have the I/O or the input-output system. Okay, when we talk about input-output system, we disregard kung ano man uri yun ng input-output system. Okay? Number 2, program must be stored in memory during execution. Yan yung the best kung bakit up until now, all the computer system architectures are still following von Neumann architecture. Lahat ng program na ini-execute ng computer, it must be stored in RAM, in random access memory. Okay? So kasi bakit? Nung unang panahon kasi, nung hindi pa sinusunod ng mga computer engineers ang von Neumann architecture, ang ginagamit pa nila, okay, for them to execute programs. So kailangan nila is first i-feed nila yung data, okay, using punch cards. Okay? Kakainin niya yung punch card and then sa kanya ma-execute yung data. Okay? And then yung result lalabas sa pamamagitan ng paper tapes. Okay? Mga papel, lalabas doon yung naka-engrave doon yung output. Okay? So there's no storage of data. Nakalagay lang siya sa punch card. And then if you feed mo yung punch card dun sa computer, sa malalaking computers, and then pagkatapos mo siyang i-feed, saka siya mag-execute ng data according dun sa data na i-feed mo. When it comes to von Neumann architecture, the program is no longer necessary to be fed. Okay? It can be stored, okay, temporarily in memory. So ganito yun, halimbawa, 'di ba, magpe-perform ka ng isang task sa computer. Addition halimbawa. So ang gagawin mo, ipapasok mo yung mga punch cards. Pasok mo yung punch card doon sa mga sinaunang computer, yung malalaking computers. And then saka ka makakapag-add kasi pinasok mo yung instruction, okay, doon sa computer para makapag-add ka. Ngayon, ganito. Let's say for example, gusto mo uling mag-addition or gusto mo uling mag-perform ng computation, ang gagawin mo ulit, ipapasok mo na naman yung mga punch cards para makapag-execute ka ulit. So, anong tawag doon? Ano yung negative side nung ganong style ng computing system? So, una, matakaw siya sa oras. It's time consuming kasi i-reload mo na naman yung instructions sa computer para makapag-execute na naman yung computer ng panibagong tawag dito, ng panibagong instruction. On the other hand, sa von Neumann architecture, sabi dito, naka-stored na yung program. Ibig sabihin, if the program is already stored in memory, you can reuse it over and over again. Kasi naka-store na siya doon. The instruction is there. Ang kailangan mo lang is kunin yung instruction na yon and i-perform yung task. Okay? Number 3. Ayan. Program instruction are executed sequentially. Ibig sabihin ng sequential, sunod-sunod. Okay? Sunod-sunod yung execution. In sequence. Hindi, tawag dito, hindi random. So, lahat naman yung instruction in sequence. Okay? Lahat naman ng instruction is in sequence ang ginagamit ng mga computer system. Okay. So, to give you the picture of the von Neumann architecture, so ito yun. Okay? So, sabi ko nga sa inyo, when we talk about computer architecture and when we talk about von Neumann architecture and the computer system, tatlo lang lagi yan. Okay? So, hindi natin kailangan isama ang hard disk, hard drives, flash drives, mouse, keyboard. Okay? General na natin siya. Kailangan na natin sa von Neumann architecture, ang computer system must have a memory to store data and program. We have the processor or yung tinatawag natin na central processing unit which is composed of two subsystem. We have the control unit and the arithmetic and logic unit. Okay? So, ano ba yung tawag dito? Control unit. Difference ng control unit at arithmetic logic unit. First, yung control unit, siya yung nag-execute ng program. On the other hand, the arithmetic and logic unit do the arithmetic and logical operation requested by the program. So, kumbaga ganito. Si control unit yung bahala mag-execute, si arithmetic and logic unit yung bahala magbigay ng instruction kung paano siya i-execute. Okay? Siya ba i-add? Siya ba ay pagko-compare? Iko-compare ba siya? Less than or greater than? Siya ba i-divide? Siya ba i-multiply? Okay? So, ang magbibigay ng instruction na yon is si arithmetic and logic unit. Okay, di ba sa mga programming languages natin, meron tayong and, or, not. Okay? Di ba? If variable 1 is equals to variable 2, if variable 1 is not equal to variable 2, do this. Okay, di ba may mga ganun tayo sa mga programming natin. Every time niraran natin yung computer system, yung program natin, the arithmetic and logic unit do that operation. Okay? Siya yung gumagawa ng logical operation. Siya nag-execute ng logical operation na yan. On the other hand, si control unit naman, siya yung mag-execute nun. Okay? So again, ALU, give the instruction. CU, do the execution. Okay? Yan yung two main parts or two subparts of the central processing unit. Okay? And of course, we have the I/O or the input-output. So, sabi dito, communicate with outside world. Yan. Screen, keyboard, etc. Okay? So, when we talk about I/O, kung ano mang I/O yon, regardless. Okay? Basta itong computer system, architecture ni von Neumann, ito ay yung bumubuo dito sa tatlong to. Pag may tatlong to, pag tong tatlong to nandun sa isang computing system, we can consider it as a von Neumann architecture system. Okay? And of course, don't forget the bus. Yan. Pag sinabi nating bus, these are the connection between these parts. Okay? So, magkakakonekta yan. Memory is connected to processor and connected to I/O or the input-output. Okay. Memory subsystem. Okay. So, memory, again, when we talk about memory, we're talking about RAM or random access memory. So, bakit ba siya tinawag na random access memory? Okay. So, may dalawa tayong uri ng memory. We have the random access and we have the sequential access memory. Okay? We have SAM and we have RAM or RAM. We have SAM and RAM. Okay? So, ano yung pagkakaiba ng RAM at saka ng SAM? Ganito. Nung unang panahon, hindi naman nung unang panahon, I mean, nung mga sinuunang computer, they are using SAM or sequential access memory. Okay? Ang sequential access memory, so 'di ba, ang mga gamit pa dati para makapag-execute ng program is in sequence. Nakalagay sa, let's say for example sa paper tapes, yung mga instruction, o kaya nakalagay sa halimbawa sa magnetic tapes. So dati hindi pa uso ang mga hard drives. Hindi pa uso din yung mga tao dito, mga flash drives. So saan natin i-store yung program? I-store mo siya sa magnetic tapes. Siguro naman nakakita na kayo ng VHS tape. Okay? VHS tape, cassette tape, yan. Kita nyo yon, ganon. Same din, malaki lang ng konti. Same din yung itsura ng magnetic tapes na ginagamit sa computer. Okay? So let's go back. Ano yung sequential access? So 'di ba, ang sequential access is if you're going to store the program in magnetic tapes, 'di ba? Kailangan mong daanan lahat ng part ng tape. Okay? Para ma-access mo yung gusto mong puntahan. Okay? Halimbawa, 'di ba, pag nagpe-play ka sa cassette tape, kailangan mong intaying matapos yung unang kanta bago mo mapakinggan yung pangalawang kanta. Hindi mo siya pwedeng i-skip. Hindi kagaya ngayon, 'di ba? May next na, next. Pipindutin mo lang yung next button, mapi-play mo na yung next na kanta. Nung unang panahon, hindi. So, iintay mo matapos. Pero syempre, 'di ba, may fast forward. So, pwede 'yon. So, but ang pinag-uusapan natin dito is yung computer system. So, ganun din. For you be able to access a specific program, ang gagawin ng computer, iikot-ikutin niya yung tape. Let's say, for example, yung kailangan niyang execute na program ay nasa dulo. Iikutin niyo yung tape para makarating siya sa dulo. Okay? Paano pag yung kaputol ng program is nasa kabilang dulo ulit? Babalik ulit siya doon para makuha ulit yung data na yon. So, that's what we call sequential access. in sequence. You need to access the data in sequence. On the other hand, we have the random access memory. Ayan, dumating yung RAM. Ang ibig sabihin ng random access memory, you can access the data uh, in random location on the memory. Okay? Pwede mong kunin yung data at any moment sa kahit saang lugar dun sa memory. Yun ang kagandahan ng random access memory. You don't need to wait for the sequence to finish. You can get whatever you want at any moment in time. So yun yung ibig sabihin ng random. Kaya nga random random access. You can access the content of the memory randomly kung nasan man yung kailangan mo. Okay? Okay? So ganun yun, random access memory. So consists of many memory cells, storage units of fixed size. Each cell has an address with it. Okay, associated with it. So 0 to so on. Okay? Depende kung gaano kalaki yung memory tawag dito, cell addresses niyan. Okay, ng RAM na ginagamit mo. All access to memory are to the specified address. A cell is minimum unit of access. Fetch, store, a complete cell. Okay, yan. So bawat isang cell, it must have an address. Okay? So ang gagawin ni CPU, kapag nag-execute siya ng program, mahanapin lang niya yung address na yon. And then kukunin niya yung laman nun. And then i-execute niya. So balik tayo doon sa sinuunang computer. Doon naman sa sinuunang computer, ang gagawin ng processor, iikot-ikutin niya yung tape para makuha yung laman. Okay? Di ba? Matagal yon. Paano kung napakahaba ng tape? Okay? Paano kung nasa kabilang dulo? So time consuming. Unlike sa random access memory, ang gagawin lang ni CPU, hanapin lang niya yung address ng cell, and then it will get the content of that cell, yung instruction na nasa loob nun. Ganun lang kasimple. Okay? The time it take to fetch, store a cell is the same for all cells. So yan, sabi dito, yung daw time na take is the same. Diba? Walang mabilis, walang mabagal. Because they are fetch the same. Ibig sabihin ng fetch, kakaunin. Okay, pagkuha. Diba? At saka daw pag-store, yung paglalagay ng laman. Okay? So, can you imagine that? Same yung bilis. Okay? Walang malayo, walang malapit. Kapag RAM ang gamit mo, random access. Balik tayo doon sa tape, hindi natin pwedeng i-apply yan. So, di ba? Hindi natin pwedeng i-apply yung same time for all cell kasi ang tape is umiikot. Okay, nagro-roll 'yan. Pwede nasa kabilang dulo yung kaputol, nasa gitna yung kaputol, 'di ba? So when the computer is running, both program and data variables are stored in the memory. Ayan. So, balik tayo dun sa pagraran ninyo ng program. So, kapag nagraran tayo ng program, kahit anong programming languages yan, PHP, C, C++, Java, okay? Once na ni-run mo yan, automatically, yung program and yung mga data variables will be loaded to the memory. Ang ipinapasok natin sa memory, hindi lang data, pati instructions. Okay? Kasi remember, kailangan ng ALU at ni CU yung mga data na yon. Si ALU ang mag-execute ng program, si CU naman ang titingin sa logical at arithmetic operations. Okay? So, yan yon. So, both programs and variables are stored in the main memory. So, sinaunang computer na gumagamit ng punch card, hindi. Ipapasok mo ang punch card, tapos i-input mo ang mga variables. Okay? Ganun. Doon sa mga sinaunang computers. Okay. So, this is an example of, tawag dito, RAM address memory cell. Okay. Need to distinguish between the address of memory cell and the content of memory cell. So, ayan. Memory width. How many bits in each memory cell? Typically, 1 byte. Ayan. Or 8 bits. So, sa isang memory cell, di ba, meron tayong 1 byte or equivalent to 8 bits. Ibig sabihin, 1 byte of memory ang pwede mong ilagay dun sa cell ng RAM. Address width or N, how many bits used to represent each address determines the maximum memory size address space. If address is N bits, then the address is 2 to N. Okay? And so on. So, ganito yan. So, bawat cell, okay? So, ganito lang ibig sabihin yan. Ang bawat cell sa memory, or yung tinatawag natin na memory cell, ang nakalagay doon is isang bit, or isang byte, sorry. Okay? So, kung gaano kadami yung cell, let's say for example, ang iyong RAM ay 2 gig. So, gaano di kadami? Okay? Ano ba ibig sabihin ng 2 gig? 2 billion. Okay? 2 billion of memory cell. More or less. Okay? And then yung address naman na tinatawag natin, that is the address of each cell. Okay? Walang pakialam ang processor sa memory cell. Ang may pakialam ang processor sa address. Kasi ang kailangan lang malaman ng CPU is address. Kapag nalaman niya ng address, alam niya kung saan niya kukunin at ipapasok ang data. Okay? Memory size and speed. Typical memory in personal computer, ayan, is 64 to 256 MB. Okay? So, siguro matagal na tong presentation na to kasi as you can see, it's 64 to 256. Pero ngayon, di ba, napakalalaki na ng ating mga, what you call this, ng capacity ng ating mga RAM, ng memory natin. Di ba? 2 gig, ang 2 gig, napakabihira na ngayon, mababa yung 2 gig. 'Di ba? Ang pinakamababa na ngayon na nakikita ko sa market, kung bibili ka ngayon ng mga laptops, is 8 gig. Yung mga memories niya. 6 gig, 8 gig, 4 gig, bibihira na. 2 gig, parang wala nang nagbebenta. Same din with sa cellphone. Sa cellphone, ganun din. Diba? Kukunti na yung nagbebenta ng mga cellphones na 2 gigabytes ang RAM. Okay? So, paano ba natin dinedetermine ang memory sizes? So, yan, kilobyte, KB. Okay, hindi eksakto na 1,000 ang isang KB. That is 1,024. Okay, 1,024 bytes. So, ang tawag natin nun is 1 kilobyte. Okay? Ang 1 megabyte naman is 1,048,576 byte. Okay? So, hindi siya eksakto na 1 million ang 1 MB. And ang gigabyte, hindi rin eksaktong 1 billion. It is 1,073,741,824 bytes. Okay? Same din sa terabyte. Okay? Ganun din yon. Hindi rin siya eksakto ang terabyte na 1 trillion. So, hindi lang naka-include dito. So, memory access time. Ayan, memory access time. Paano ba natin na-determine yung speed ng memory? Okay, syempre, ang titingnan natin dyan is yung clock speed or memory access time. Ang ibig sabihin ng memory access time, gaano kabilis siyang ma-access ni CPU at gaano kabilis siyang malagyan ng laman. Okay? The faster the access time, okay? The lesser the access time, the faster the memory is. Okay? Pagbaba ng access time, pagbilis ng memory. Siyempre, 'di ba? Kung papasok ka diyan kung titingnan mo lang yung processor natin sa CPU, napakabilis nung processing ng data. Okay? Sobrang bilis. Okay? Napakabilis. So, memory access time, read from and write to memory. So sabi dito 50 to 75 nanosecond. Okay? 'Di ba? Gaano ba kabilis ang nanosecond? Napakabilis niyan. Hatiin mo siya ng how many is this? Ayan natin. I think nanoseconds, you're going to divide 1 second in 1 million. That is nanosecond. 'Di ba? Mabagal na to. Kasi yung ngayon, mas mabibilis na. Imagine 50, 75 nanoseconds. So, in today's standard, mas mabilis pa yung ngayon. I think mga nasa 20 nanoseconds na lang yung access time. So, RAM is volatile. Yan, RAM is volatile. Can only store when power is on. And relatively expensive. Ayan. So, bakit ba mahal ang RAM? Okay? Bakit mahal ang RAM compare sa ibang tawag dito? Bakit ba mayroon pang RAM? Yun, minsan. Hindi nyo ba naitanong, bakit ba mayroon pang random access memory? Bakit hindi na lang hard disk na lang? Malaki pa yung capacity. Excuse me lang. Hello po. Okay. So sabi dito, RAM is volatile. Okay, kasi hindi siya nag-retain ng laman. Kapag pinatay mo ang computer, automatically, all the content of the RAM will be deleted or erased. Okay? And relatively expensive. So bakit ba mahal ang RAM? On the first place, bakit ba kailangan may RAM pa ang isang computer system? Bakit hindi na lang ang gamitin natin ay hard disk, 'di ba? Hard drive. Mas malaki pang capacity. 'Di ba? May hard drive na 1 terabyte. Oh, ba't hindi na lang 'yon? The answer is the speed limit. Okay? Okay? I-discuss natin 'yan pag dumating na tayo sa memory hierarchy. Ang ibig sabihin ng speed limit, hindi kaya ng speed ng hard drive sumabay sa speed ng processor. Remember, processor is a very, very powerful machine. It is super fast machine. Okay? Therefore, it requires fast memory. Okay? So, hindi natin pwedeng ikabit ang hard drive para i-access ng CPU. Bakit? Napakabagal ng hard drive kung ikukumpara mo sa takbo ng CPU. Okay? So, fast machine needs fast memory. Kasi imagine niyo, every nanosecond kailangan niya mag-read and write ng data. Kailangan niya bumasa at maglagay ng data. Paulit-ulit yun. Okay? Nanoseconds. Sobrang bilis. Wala pa 1 segundo. Kailangan niya mag-read and write. Pag ginamit natin ang hard drive as primary storage, ay hindi makakasabay ang ating hard drive. Imagine, napakabagal ng hard drive mag-read at mag-write ng data. Sa atin, in human perception, mabilis. Diba? Pag binuksan mo yung program, pag nag-open ka ng Microsoft Word, mabilis. Sa atin yun, sa perception natin yun. But on the perception of the CPU, napakabagal. Kung ikukumpara mo ganito, kung ikukumpara mo ang bilis ng processor sa hayop, siya ay cheetah. Yan. Alam niyo man cheetah. And ang hard drive, kung ikukumpara mo sa hayop ay pagong. Okay? Imagine, nakikita nyo na-perceive nyo yung pagkakaiba ng bilis nila. Imagine niyo sasabayan niya ng processor yung hard drive. It can't be. Okay? The access time would be increase. So kung nanosecond niya ina-access yung data, baka abutin niya ng segundo. Wag pala 10 seconds. Napakabagal ng processing ng computer natin. So therefore, the processor need a high-speed type of memory, which is RAM. Okay? It needs a high-speed memory, which is RAM. So kung si processor ay si Cheetah, siguro wag, si RAM ay pwede natin i-compare sa kabayo. Okay? At least medyo nagpapanghabol yung bilis niya. Okay? So yun yun. Hindi natin pwede. Kaya naman expensive siya. Why? Because the manufacturing materials, the manufacturing cost and the materials that being used in manufacturing random access memory is expensive. Mamahalin. Okay? Mahal. So yun. Pero ngayon mura na, hindi na ngayon ganun kamahal, di ba? Because the manufacturing cost is much lower kumpara nung mga nakaraang taon. Napakababa na ng manufacturing cost ngayon ng call this ng RAM or ng random access memory. So yun. Okay? So again, the CPU needs RAM for it to access and write data. Okay? So ganito kasi ang nangyayari dyan. Ang RAM, nakikipag-communicate siya sa hard drive. Okay? Ang CPU nakikipag-communicate kay RAM and ang RAM nakikipag-communicate kay hard drive. So hindi po pwedeng dumirekta si processor kay hard drive kasi hindi sila magkakasundo. Okay? So yun. So halimbawa, nag-open ka ng program. So, 'di ba? Nag-save ka ng program nag-save ka ng document, 'di ba? Saan natin sinasave ang document natin? Sa My Documents, nag-save ka. Resume.docs. Yan. So, saan nyo nakasave? Sa hard drive. Dinouble click mo, inopen mo. Ang mangyayari doon, bago siya mag-open, once na dinouble click mo yun, ang mangyayari doon, i-fetch siya papunta sa RAM. Dadalhin yung Microsoft Word, dadalhin yung document kay RAM. Okay? Saka pa siya ipaprocess si processor. Pag na-process siya ni processor, ibabalik siya sa kay RAM. And then, saka pa siya magdi-display sa monitor mo. Saka siya mag-o-open. Pero, di ba, pagka-click mo, nandyan na. Ang bilis, di ba? It's an instant kasi mabilis yung processing. Okay? Ng CPU. So, ganun yun. So, operations on memory. Yan, fetch address. Fetch a copy of a content of memory cell with specified address. Okay, non-destructive copies in memory cell. Store address and value. Store a specified value into the memory cell specified by address. Destructive overwrites the previous value. So yan, ang ibig sabihin ng fetch, kukunin niya yung data. Kukunin lang, wala siyang gagawin. It's called non-destructive kasi kukunin lang niya yung laman. Okay? Ngayon, yung store. Pag store na, ibig sabihin, i-modify na yung laman. Ang gagawin niya, di-delete niya yung dating laman, i-update niya ng bago. Okay? Ganun din. Halimbawa, kita mo, nagtatype ka sa Microsoft Word. Okay. Every time na nagtatype ka sa Microsoft Word, nangyayari yon fetching and storing. Okay? Fetching and storing, nangyayari yun kada segundo, every second, buhay ang computer. Fetching and storing. Hanggat gumagawa ka dyan sa laptop mo, the fetching and storing process always happening. Okay? Nagtatype ka. So, pagka-type mo ng mga letters, ang gagawin yan, kukunin niya yung mga letters na yun, i-update. Kukunin ng CPU, dadalhin kay RAM, and then from RAM, i-access sa CPU. Ipaprocess niya. Fetch, store, display, fetch, store, so on and so on, until matapos ka. O ganun ang nangyayari sa computer natin. So, the memory system is interfaced via Memory Address Register or MAR memory data register, and we have the fetch store signal. So yan. So yung mga memory, yung MAR, MDR, fetch store signal, so ang nakaka-access lang dyan, of course, is the central processing unit. Okay? Central processing unit. So pwede mo bang malaman yung laman ng RAM memory? Oo naman. Okay, pwede mo malaman yung laman ng iyong random access memory. Kung ano yung mga current na laman niya, pumunta ka sa Control Alt Delete. Okay? And then makikita mo yung different processes na nagraran. Yun ang laman ng iyong random access memory. Diba? Minsan, naglalag yung computer natin. Tingnan natin yung ating task manager. Okay? Control Alt Delete, task manager. Tingnan mo doon kung alin yung may pinakamalaking kumain ng memory. Yun ang nagiging sanhi kung bakit naglalag ang iyong laptop. Usually, pinakamalaking kumain ng memory is Google Chrome. Yan. Bawa, nag-internet ka lang naman, malakas kumain ng memory ang Google Chrome. Diba? Ano pa? Yung mga high-end na laro. Diba? Bakit siya naglalag? Kapag mababa ang memory mo. Kasi, kakainin niya na yung memory. Okay? Hindi na makagalaw yung ibang system. Kumbaga parang siksika na sila doon. Okay? So, hindi na makahinga yung ibang processes. So, nagkakaroon tayo ng lagging. Okay. Structure of the memory subsystem. So, yan yun. So, we have the MAR, memory decoder circuit, and we have with the MDR for fetch store controller. So, ayan. So, yung dalawang yan yung dalawang yung pinaka-interface na ina-access ng CPU. Okay? Memory decoder circuit. So, we have the fetch and decode. Fetch and store controller. Okay, sabi dito, diba? Fetch address, load address to MAR, decode address in MAR, copy the content of memory cell with specified address to MDR. Okay? So, si MAR, siya yung nagkumukuha ng address. Sa MDR naman, siya yung kakaon dun sa program. Same din kapag ka magra-write na. Okay? So, yan yun. Copy the content to MDR. So, dalawa lang ibig sabihin yan. MAR, yung address, it directs the execution to the address of the memory cell. The MDR will fetch the content or store the content to the cell. Input-output subsystem, or we have the I/O, tinatawag natin. Handles device that allow the computer system to communicate and interact with outside world. Ayan. Ano ba yung outside world natin? Siyempre, yung mga hardwares natin. Screen, keyboard, printer. When we talk about the I/O, kagaya sinabi ko sa inyo kanina, we talk about generally all the input-output hardwares. Kung ano man meron tayo. Excuse me. Screen, keyboard, printer. Ayan. Store information. Hard drive, floppy drive, CDs, and tapes. Ayan yung sinasabi ko sa inyo kanina. So, di ba? Sa von Neumann architecture, hindi kasama ang mga hard drives. Kasi labas yan dun sa architecture. Okay? So, kasama siya sa I/O. Mass storage device, access methods, direct access storage device. Yan, sequential access storage, tape, example, used as backup device. Pero wala nang gumagamit ngayon ng tapes. Okay, as storage, wala na. Mostly, nakikita ko na gumagamit yan, yung sa mga, sa mga museum, sa mga computer museum. So dinidisplay nila kung paano ginagamit yung mga computers, mga sinaunang IBM computers na gumagamit pa ng mga magnetic tapes to store data. Most of the day wala na. Floppy drive wala na din. Okay? Wala nang gumagamit. May gumagamit pa pala ng floppy drive. The US Department of Defense. Okay? So alam nyo ba, ang US Department of Defense, ang ginagamit pa rin nila para patakbuhin ang kanilang mga missile ay disket. Okay? And then, ang ginagamit pa rin nilang computer ay yung sinaunang Commodore computer. Okay? So bakit ganoon? Bakit hindi modern ang ang computer ng National Defense ng US sa pagkokontrol ng mga missile, ng mga nuclear missile? Okay? So tingnan niyo sa YouTube, mapanood niyo 'yan, yung US Nuclear Defense still using diskette. Yan, makikita niyo doon. So bakit ganoon? Kasi hindi nila ina-upgrade yung technology. Okay? Hindi nila ina-upgrade yung technology para hindi siya prone for hacking. Hindi siya mahahack. Kasi nga obsolete na yung technology. Wala nang ganun technology. Paano pa siya mahahack? Okay? Mahirap na siyang i-hack. Kasi lumang-luma na yung technology. So, if your question if is it still working? The answer is yes. It's still working. And they are using, alam niyo yung kung ilan gamit, yung disket na gamit nila. Hindi pa yung modern disket ha. Ang gamit nila yung 8 inches disket. Malapad na disket. And ang laman lang niya, memory capacity is few kilobytes of memory lang yung laman niya. Okay? But it's still working. Kapag nagkaroon ng digmaan at gusto niyo magpalipad ng nuclear weapon, gumagana pa din yung system na yun up to this moment. Okay? And parang wala silang planong i-upgrade yung kanilang computer system. Okay, I/O controllers. Speed I/O device is slow compared to RAM. So, yan yung sinasabi sa inyo kanina. 'Di ba? So, look at this. RAM, 50 nanosecond. Hard drive, 10 milliseconds. Yan, napakalaki ng agwat nung speed. Yan sinasabi sa inyo, cheetah pagong. So, therefore, the CPU cannot interact with hard drives and other drives. Kahit flash drives yan. Okay? Kasi napakabagal niya. Solution, I/O controller, special purpose processor, has small memory buffer and the control logic to control I/O device. Example, move disk arm, send an interrupt signal to CPU when done read and write. Ayan. So, ano yung solution para makahabol sa bilis ng CPU ang mga I/O devices? Meron tayong tinatawag na I/O controllers. Bawat device, input-output device, meron niyang maliit na microprocessor sa loob. Parang mini CPU. And those mini CPUs are capable of communicating with the processor. Okay? Siya yung nakikipag-communicate. Ang tawag din buffer, di ba? Nagkakaroon ng memory buffer. Pero lahat yan dadaan kay RAM. Siyempre, walang direkta na pumupunta kay CPU. Dadaan yan kay RAM. And then from RAM, i-access yan ni CPU. And then from RAM ulit, ibabalik ni CPU, papunta kay RAM, papunta ulit dun sa mga I/O controllers. Lahat ng ginagawa natin, lahat ng nakikita natin sa screen, lahat ng pinipindot natin, dadaan yan lahat kay RAM, papunta sa processor, and ibabalik niya yan, papunta kay RAM, pabalik sa kung saan bang niya dapat ibalik yon. Okay? So yan, data transfer between RAM and memory buffer. Processor free to do something else while I/O controller reads writes data from or to device into I/O buffer. So yan, may buffering na nangyayari. Okay? Buffer communication ang tawag. May buffer communication between I/O device papunta kay RAM and of course from RAM to CPU. Again, I/O devices cannot communicate directly to CPU. Kasi nga, mabagal sila. Okay? The only thing they are capable of is via I/O controller. Okay? I/O controller connects or communicate to the RAM papunta sa CPU. Ayan. So, ito yon. Look at I/O device. So, I/O device. So, we have what you call this? The control logic. Okay? So, sa loob ng I/O controller, meron tayong dalawang sub system. So, we have the I/O buffer and we have the control logic. So, halimbawa, ginagalaw natin yung mouse natin. Okay? This control logic and I/O buffer send signal. Okay? Papunta kay RAM. Oy, ginagalaw niya yung gumagalaw yung yung mouse. Okay? Oy, kinilik yung mouse. May buffering na nagaganap. Pagka-click mo ng mouse, automatically magsesend yung signal papunta sa RAM, papunta sa CPU. I-interpret ng CPU ano yung ginawa mo, bakit ka nag-click. And then, i-execute niya kung anong ibig sabihin ng click mo yan. Pwedeng nag-click ka dahil nag-open ka ng program. Nag-click ka kasi nag-refresh ka. Nag-click ka kasi nag-i-scroll ka ng browser. Okay? So, yun yun. So, there's a buffer. Okay? And when we say interrupt, okay, interrupt signals, ang ibig sabihin ng interrupt ganito. Every time na may ginawa ka sa I/O mo, bawa mouse nga, balik tayo sa mouse. Pag nag-right click ka, automatically magsesend yan ng interrupt signal kay CPU. Sasabihin ng interrupt signal, hoy CPU, stop. Nag-right click ako. Okay? So, ang gagawin CPU, titigil niya lahat ng ginagawa niya. Pupunta siya kay mouse. Hanapin niya anong ibig sabihin ni mouse, anong ginawa niya. Okay? Pero mabilis yon. Diba? Nanosecond lang. Hindi natin napapansin. Okay? Sa human perception, it can't be noticed kasi napakabilis ng processing. Okay? Human perception is so fast. Okay? So, when I/O sends interrupts, napakabilis. So, it tells the CPU to stop what it's doing and the CPU will stop and check kung ano yung ibig sabihin ng interrupt signal. Okay? So, that is the I/O subsystem. Okay, let's go with ALO subsystem or arithmetic and logic unit subsystem. So, the ALO or arithmetic logic unit performs mathematical operation and we have the logical operation. So, pag sinabi nating mathematical operations, these are the common mathematical operations that we had. Multiplication, addition, subtraction, squaring of numbers, diba? Polynomials, decimals, what you call this? Getting of remainders of numbers. On the other hand, we have the logical operation. When we see logical operation, this the CPU performing logic operation. Example, comparing numbers. Which one is greater and which one is has lowest value? Are they equal? Okay? Are they not equal? Diba? When we execute our program, let's say for example, we have or and not and. Okay, those are done by arithmetic and logic unit. In today's computer, integrated onto CPU. Ito na nga yun. ALO is integrated already on the CPU. Sino ga-ari natawag na ari? Yes, hello po. Apo? Yes, ma'am. Apo. Apo, ma'am. Ma'am, hindi pa po. Magkano po ba yung amount po? Apo. Kasi sige po, ma'am. At ano ko po. Opo, sige po ma'am. Salamat po. Okay, in today's computer, the arithmetic and logic unit already embedded within the CPU. So consists of circuits to do arithmetic and logic unit or logic operation, register, fast storage unit to store intermediate computational result, bus that connects the two. So ayan yun. So registers, very fast. So ito yung structure ng arithmetic and logic unit. So we have the register. Register is a very fast local memory cell that store operands of operation and immediate result. Okay? CCR or condition code register, a special purpose register that stores result of less than equal greater and when less than equal or greater than operations. Allo circuitry contains an array of circuits to do mathematical and logic operation. So ayan, yung ibig sabihin ng register. So sa loob ng CPU, meron pang maliit na memory. Ang tawag sa kanya is register. It is a super fast memory and napakaliit lang nung kanyang capacity. Diba? Maliit lang. Siguro mga few kilobytes lang. Pero sobrang bilis niya. Okay? It doesn't need, hindi niya kailangan ng malaking capacity kasi sobrang bilis niyang magbura at maglagay ng laman. Therefore, hindi niya kailangan ng malaking capacity. Okay? Pag kailangan niyang lagyan ng laman, kaya niya agad burahin yung laman niya and ilagay yung bago. In nanoseconds. Ganun kabilis. Okay? So, sa register, doon nag-i-store yung tawag dito mga operands. Kung ano yung ipe-perform ng arithmetic and logic unit. Okay? And yung immediate result. So, after ng computation, lumabas yung result ng computation, lalabas niya agad dun sa register. Okay? So, bus, of course, ang bus, pag sinabi nating bus, these are the data path or yung connection between the different units. Okay, the control unit. Program is stored in memory as a machine language instruction in binary. Okay. Task of the wait lang ha, hindi natin makita. Kulay dilaw. Yeah. Okay, let's go back. Yan. Control unit. Program is stored in memory. Kagaya nga na sinabi ko sa inyo. Diba? Lahat ng ginagawa natin, lahat ng program must be stored in the main memory or RAM. As machine language instruction in binary. Siyempre, ang nakastore doon is hindi regular text characters. Ang nakastore doon is binary. Lagi naman. Okay? Lahat ng ina-execute ng CPU is in form of binary. The task of the control unit is to execute program by repeatedly fetch from memory the next instruction to be executed, decode it, that is determine what is to be done, and execute it by issuing appropriate signal to the ALU, memory, and I/O subsystem. So, yan yun. Trabaho ng control unit. So, ito yung ginagawa niya. Paulit-ulit lang to. This is a cycle. Una muna, kukunin niya ang instruction sa memory. Diba? Kukunin niya. Siyempre, para makuha niyo, dapat alam niya yung memory address ng cell. Aalamin niya yung memory address ng cell. Pag alam niya na, pupuntahan niya yung cell, kukunin niya yung data na nandoon. Okay? Kukunin niya yung laman. Remember, ang isang instruction ay pwedeng millions of cell. Okay? So, ibig sabihin, dapat alam ni control unit yung lahat ng address na yun, yung milyong address na yun para makuha niya yung instruction. And it happens in nanosecond. Napakabilis. After that, kapag nakuha niya na yung instruction, i-decode niya na. Ay, ibig sabihin ng decoding, aalamin niya, ano tong instruction na to? Ano ba ang kailangang i-perform? Addition ba? Subtraction ba? Multiplication ba? Division ba? Comparing ba ng numbers? Less than? Greater than? Ngayon, pag nalaman niya na yun ngayon, ang gagawin niya, isesend niya yun kay ALU. Kasi si control unit, hindi niya kayang mag-solve ng problem. Ang kaya lang niya, kumuha at kontrolin yung pagkuha at pagbabalik. Okay? So, ang gagawin niya, ibibigay niya kay ALU, o ALU, ito na, ipe-perform daw, addition daw. So, gawin mo. So, gagawin ni ALU. After magawa ni ALU, ganun ulit ang gagawin ni control unit. Kukunin niya ulit yung data. Okay? I-decode niya ulit yung data kung saan siya, kung anong gagawin doon sa data ngayon at ibabalik niya sa memory cell. Okay? Kung yun ay result, di ilalagay sa memory cell yung result. Okay? Kung yun ay error, dahil mali yung program, ay di babalik niya sa memory cell is error. Ganun lang yun. Okay? Control unit do the fetching, the execute, do the fetching, the decoding, and the execution. Okay? But the actual computation is ang gumagawa nun is si ALU. Okay? Magkatulong silang dalawa. Okay? Continuous until halt instruction. So, titigil lang yung cycle na yon kapag wala na siyang kailangang gawin. So, for example, end na. Titigil na yung si control unit. Okay? So, yan. Yari, walang laman. Hindi makita. So, ayan. Assume opcode add is 9, address is x equals to 99, y is equals 100. So, ayan. Opcode. Opcode for add is 9. Okay. So, makikita natin dito, meron tayo dito tatlong memory cell. Okay. Meron tayong mga tatlong memory cell dito. So, we have opcode. Ang ibig sabihin ng opcode is ano yung task na ipe-perform. Diba? Ano yung instruction na ipe-perform. And then, yung namang addresses na address 1 at address 2, yun yung data na i-execute. So, for example, 99 tsaka 100. Yan. X is equals 99, y is equals 100. So, yan yun. Yun yung mga addresses na pupunta niya. So, kukunin niya yung opcode. Opcode is the operation. Address 1 and address 2 are the data. Okay? Na kailangan niyang execute. So, kung pag-a-add din niya yung dalawang number na nandun sa address na yon, so, yun ang gagawin niya. Ipe-perform niya. Okay? Okay. So, meron tayong dalawang instruction set design. So, we have two different approaches. We have the reduced instruction set computers. So, sabi dito, instruction set are small and simple as possible. Minimize amount of circuitry for faster computing. On the other hand, we have the complex instruction set computers, or the CISC. More instruction, many very complex. Each instruction can do more work, be required more circuitry. Okay, balikan natin to. Okay? So, ayan, instruction set design. Okay. So, now, hanggang dito muna tayo. Dito matatapos ang ating discussion sa instruction set design. So together with this video, I will be together with this lecture, I will be uploading tawag dito, a documentary regarding this two instruction set design. Okay, the risk and the CISC. So I want you to watch them, and then later on mag-upload ako ng question ng activity number 1 natin. Okay? So ang tawag doon sa activity natin is self-assessment. Okay, self-assessment 1. So mag-upload ako, and then ipo-forward nyo na lang yung sagot ninyo sa akin via Messenger. Okay? So yan. So I hope na pinanood nyo yung buong natin discussion. And nga pala, pinapatanong ni Sir Adrian yung inyong compliance kasi hindi daw yata kayo nagko-comply sa subject ninyo sa calculus. So kindly chat him and coordinate with him. Okay? So that's all for today. So thank you so much sa inyong pakikinig. So again, so panoodin nyo rin yung video na kasama nito about the risk and the CISC architecture. Ano yung pagkakaiba nila? Which one is better? Okay? So, yun. Para mas maintindihan nyo yung architecture ng microprocessor. Okay, ng CPU. Okay? So, thank you.